application of truth table of switching network. So here we are going to perform the application of the truth tables of the network, that is the switching network, under the part number 2 in an advanced level. So here in this regard a circuit will be given, that is the circuit network will be given, then based upon the truth values of the circuit network, then we have to determine whether the current flows from the terminal A to the terminal B or not. So here let us illustrate this application of the truth table by means of the switching network by means of one illustration, that is an example. So in this example we will determine, or in other words we will find when the current flows from the terminals, that is A to B in the circuit network that is given. So here the network which is given to us is of, so this is the terminal A, and whereas so here there are of two switches, one is of P and the other switch is of P dash. Then in parallel there is another switch which is nothing but the Q, then it is connected to the terminal, that is B. Whereas as per the circuit network which is given, so here the current flows from terminal A to B through the series of the switches, that is P and as well as P dash, and in parallel there is another switch, that is Q. So this can be expressed in this way, that in the, whereas in the next logical step the solution starts now. So in our solution, so here as per the circuit network which is given, the current flows from the terminals that is A to B through the series combination of the switches. So here the switches which are arranged in series are of P and as well as P dash. Then now, so this can be given by means of, so here then we have symbolically we can denote by means of, so here P and P dash. And the similar manner in the second case, the current flows from the terminal, that is A to B, that is in parallel combination of switch that is arranged as Q. Then overall, say here then we have the behavior of the circuit network so here the behavior of the circuit network can be shown by truth values in the truth table of the condition. So here, since P and P dash are the switches which are connected in series, so here we can write it by means of, so here P and P dash, but whereas here the in parallel, so there is a switch which is connected, so therefore we can write it as RR, that is current passes through the from the terminal A through P and as well as P dash, or in other words the switch that is R Q. So therefore, so when we have to find out the truth values of this condition, that is P and P dash or Q, then in the truth table. So by that it is clear that, so in case if we get the truth value of the condition, that is P and P dash or Q in the last column as T, then it is understood that the current flows. Whereas if the truth value in the last column of the P and P dash or Q is of false, then it is understood that the current does not flows. And in the similar manner, so when we get the truth value as T, then it is understood that the switch is closed. And for the truth value F, it is understood that the truth value, in case if it is F, the switch is observed to be the open. Then based upon these conditions, we have to find out the truth values of P and P dash or Q in order to know, or in order to determine whether the current flows from the terminal, that is P, to the Q. Whereas in the next logical step, we have to find out the condition, that is P and P dash or Q. So here this is the truth table. Then whereas in our truth table, so here we have to assume two statements, that is one as P, then the other as Q. Then now in the next column, say we have to find out P dash, that is not P, or in other words the negation of the statement, that is P. Whereas in the next column, let us find out this statement, that is P and P dash. Then overall in the last column we are going to find out P and P dash, then RQ. Then now, so these are the 5 columns in which we have arranged P, Q, P dash, P and P dash, and as well as P and P dash RQ. But here when we assume a single statement, it is understood that a statement may be either true or false, but not both. But here we have assumed two statements, P and Q. Therefore, there will be 4 possibilities. The two statements, the truth values of the two statements may be true or may be false. If the statement, that is P, is of true, then we can assume the truth value of the second statement as false. Then when we assume the first statement truth value as false, then we have to assume this statement, that is Q, truth value as true. So here these are the 4 possibilities, both may be true and both may be false. If one is of true, then the second will be of false. If this truth value of the first one P is of false, then the second automatically it will be of true. So here these are the 4 possibilities. Then now we have to find out P dash, that is not P. So here if the truth value of the statement P is of true, then not P. So if it is of not true, then automatically it must be of false. Then the truth value of P is of true again, then the P dash not P, that is the not true, it will be a false statement. The remaining two truth values of the P are of falses, then the P dash will be of true in both the cases. Then in the 4th column we have to find out P and P dash. Here the connective is of AND, therefore it will come under the conjunction. We have to find out the conjunction of the two statements, that is P and P dash. So here in case of a conjunction, the condition is of the first statement truth value is of T, that is true, and the second truth value is also of true, then now the conjunction also will be of true. So here P is under the column number 1, and P dash is under the column number 3, we have to search under P dash, that is P and P dash of columns 1 and 3 in order to get the conjunction of the two statements, that is P and P dash. So here both the truth values of P and P dash must be of true in order to get the conjunction as true. So here T and T under 1 and 3 columns, so here it is of T and F, is also of T and F, so it is of F and T, and it is also of F and T. So we won't get the disjunction as conjunction as true, so we will be getting the conjunction statement as false in all the cases. Then now in the last column we have to find out P and P dash or Q. Here the connective is of R, we have to find out the disjunction, because here since the connective is R, so here it will come under the disjunction. So under the disjunction the condition is of, if the first statement P and P dash is of false and the second statement truth value is also of false, then therefore the disjunction also will be of false. So P and P dash lies under the column number 4 and Q lies under the column number 2. So we have to see under column number 2 and as well as 4 in order to get the disjunction, that is F and F as F. So we have to search for F and F under columns 2 and as well as 4. So it is of T and F and it is of F and F. So both the truth values of Q and as well as P and F, P and P dash are of true, false, therefore the disjunction also will be of false. So it is of T and F, we can avoid it. And the last row, so here in case of last row the truth value of the Q is of false and the truth value of P and P dash is also of false, therefore the disjunction will be of also false. Then now the remaining will be of true. So here we know that when the statement is of true, that is the P and P dash or Q is of true, then only the current flows. Whereas in the third case also the current flows since it is of true, whereas since it is F, it does not flow in the remaining two conditions. Then now, but here we know that in the first case it is the current is flowing, whereas if the statement P is of true, for T we have to assume it as closed when the switch P is closed in the first condition, and whereas the switch Q is also closed, whereas since it is F, so it F indicates open, so P dash must be open in order to flow the current from terminal A to terminal B. So here we can write it as, so here the current flows from terminals A to B when, so here it flows in the first condition. So in first case P is of true, so T indicates closed, switch is closed, so here switch P is closed, and here Q is also of T, that is Q is also of closed, and here P dash is F, that is P dash is open. And in the third case the current flows, whereas in the third case, so switch P is of F, I say F indicates it is open, so where P must be open, and remaining two switches, that is Q and P dash, must be of true, that is T indicates closed. So here Q must be closed and as well as P dash also must be closed. So in these two cases the current flows from the terminals, that is A into B.